Hello good people, I'm going to look at a strategy that can help us when balancing chemical reaction equations. Often, when we balance a chemical reaction equation, it can become tricky to keep track of how many atoms are present. I'm going to show you an account keeping method. It is not necessarily the fastest, but it can help. Here we have an equation between aluminium and hydrochloric acid that will give us aluminium chloride and molecular hydrogen. To help me balance this reaction equation, I'm going to list all of the reactants and products present in terms of the atoms. Both sides, I have aluminium, chlorine and hydrogen. Why did I list them in this order? Well, I'm trying to follow guideline number 2. Metals first, then non-metals, then hydrogens. How does this list help me? I'm going to start by giving the number of each atom present. On the reactant side, right now, I have 1 aluminium, 1 chlorine, and 1 hydrogen. Side, I have 1 aluminium, 3 chlorines, and 2 hydrogens. Aluminiums are already balanced, beautiful, but the chlorines are not. On the product side, I have 3, and on the reactant side, I have only 1. To fix that, I'm going to multiply hydrochloric acid by 3. And now again, I'm going to list how many atoms I have. Still 1 aluminium, 3 chlorines, but now 3 hydrogens. What about the product side? Well, nothing has changed there, so I'm just going to copy the numbers. Now the aluminiums and the chlorines are balanced, but the hydrogens are not. Currently, I only have 2 hydrogen atoms on the product side. So I'm going to increase that by placing a coefficient of 2 in front of molecular hydrogen. How has this affected the number of atoms present? Nothing has changed on the reactant side, so I can just copy those numbers down. But on the product side, things have changed. Yes, I still have 1 aluminium, 3 chlorines, but now I have 4 hydrogens. This is going to require a bit of back and forth. In order to balance the hydrogens, I'm going to need to replace this coefficient of 3 with a coefficient of 4. So let me do that. On the reactant side, I have 1 aluminium, now 4 chlorines and 4 hydrogens. On the product side, 1 aluminium, 3 chlorines and 4 hydrogens. So balancing the hydrogens has upset the number of chlorines. To fix that, I'm going to increase the number of aluminium chlorides. Currently I only have 1. I'm going to place a coefficient of 2. Now on the product side I have 2 aluminiums, 6 chlorines and 4 hydrogens. On the reactant side I have 1 aluminium, 4 hydrogens and 4 chlorines. So I have managed to balance the hydrogens, but in doing that, I have upset the aluminiums and chlorines. Which one should I fix first? Aluminiums or chlorines? Well, I'm going to follow guideline number 2, which means I'm going to deal with the metals first. So I'm going to place a coefficient of 2 in front of aluminium. Now I have 2 aluminiums, 4 hydrogens and 4 chlorines on the reactant side, and 2 aluminiums, 6 chlorines, and 4 hydrogens on the product side. To fix the chlorines, I need to increase the amount of hydrochloric acid. Currently, I only have 4 chlorines, but I need 6. So I'm going to replace this 4 with a coefficient of 6. And again, I'm going to see what has happened to my numbers. I still have 2 aluminiums, this time 6 chlorines and 6 hydrogens. On the product side, 2 aluminiums, 6 chlorines and 4 hydrogens. The number of aluminium atoms and the number of chlorine atoms is balanced, but the number of hydrogens is not. On the product side, I only have 4, but I need 6. If I change this coefficient of 2 into a 3, I will have balanced the hydrogens. Let me check the numbers of atoms. I haven't done anything to the reactant side, so I can simply copy the numbers. And now on the product side, I have 2 aluminiums, 6 chlorines and 6 hydrogens. All the reactants and products are now balanced. Yes, this method takes a while, but it allows us to track the number of atoms present on the reactant and the product side. Let me do one more. In this case, we have ammonia reacting with oxygen at a balmy 1000 degrees Celsius to give nitrogen monoxide and water. On the reactant side, I have 1 nitrogen, 3 hydrogens and 2 oxygens. On the product side, I have 1 nitrogen, 2 hydrogens and 2 oxygens. On the reactant side, I have 3 hydrogens coming from the ammonia, and on the product side, I have 2 hydrogens coming from the water molecule. 3 and 2 are common factors of 6. So if I want to get to 6 by using 2, I need to multiply it by 3. By the same token, if I want to get to 6 by using 3, I need to multiply it by 2. What has that achieved? Well, now I have 2 nitrogens on the left-hand side, 6 hydrogens, and 2 oxygens. On the product side, I still have 1 nitrogen, 6 hydrogens, and 3 oxygens. By balancing the hydrogens, I have upset the nitrogens. To fix that, I need to increase the amount of nitrogen monoxide on the product side. I'm going to place a coefficient of 2. How has that changed the numbers? Well, on the reactant side, everything remains as before. But on the product side, now I have 2 nitrogens, still 6 hydrogens, but now 5 oxygens. 2 coming from nitrogen monoxide and 3 coming from the water molecule. We are almost there. We just need to balance the oxygens. The left-hand side, I only have 2 oxygen atoms. But on the product side, I have 5. How do I go from 2 to 5 by using multiplication? In other words, what do I need to multiply 2 by to get to 5? Alternatively, I could say, what do I get if I take 5 and divide it by 2? The answer is 2.5. And I'm going to place that coefficient in front of molecular oxygen. As a result, on the reactant side, I have 2 nitrogen atoms, 6 hydrogen atoms, and 5 oxygen atoms, because 2.5 multiplied by 2 is 5. Nothing has changed on the product side, so I have 2 nitrogens, 6 hydrogens, and 5 oxygens. From a mathematical point of view, everything is balanced. However, in chemistry, when it comes to chemical reaction equations, we like to deal with whole numbers. What do I need to multiply 2.5 by to get to a whole number? Well, if I double it or multiply it by 2, I will end up with 5. So let me do that. Here at the bottom of the screen, I have rewritten the chemical reaction equation. This time, I have doubled the number of oxygens. However, I have to be careful. By doubling the number of oxygens, I have upset the balance. I have 10 oxygens on the reactant side and still only 5 on the product side. How do I fix this? It turns out that whenever we are dealing with chemical reaction equations, we are dealing with directly proportional ratios. In short, when dealing with directly proportional ratios, whatever happens to one component must happen to the others as well. In this particular case, we have multiplied the molecular oxygen by 2. In order to keep everything nicely balanced, the entire reaction equation needs to be multiplied by 2. Every single component needs to be doubled. And now, instead of 2 ammonia, I will have 4 ammonia molecules. Instead of 2 nitrogen monoxides, I will have 4 nitrogen monoxides. Instead of 3 molecules of water, I will have 6 molecules of water. Although you may doubt me, balancing of chemical reaction equations becomes easier with practice. As before, the main thing to keep in mind are the 2 guidelines written above. That is all for now, and I will see you on the flip side.